Hello, dear students. Good morning. How are you? I hope yesterday the concept of overtaking distance you must have understood. We were just touched upon overtaking zone. This is the overtaking zone wherein the width of the road is increased. The desirable and minimum length of overtaking zone 3 to 5. 3 is minimum, 5 times OSD is the desirable length wherein the overtaking operations could be easily possible. However, in order to bring to the notice of the driver of the vehicle that overtaking zone is started, signposts are required to be installed for both the direction of movements. For one direction of movement, say left to right, 2 signposts at a distance of 1 OSD as shown in figure. Similarly, for the other direction of the movement, also 2 signposts are required to be installed. This is starting of the overtaking zone, this is end of the starting zone. For this direction of movement, this is starting and this is end. Now we will solve numerical problem. Before to that, what is the maximum and minimum values of OSD for different speeds range? This is the speed range 40 to 100. 40 to 100 km per hour. For 40 km per hour, the distance works out to be 165 meter. For 100 km, it is 640 meter in between the variation that you can see from the table. Next, example 1. The speed of overtaking and overtaken vehicles are 70 and 40 km per hour respectively on two-way traffic road. If the acceleration of overtaking vehicle is 0.99 meters per second squared per second, calculate the safe overtaking side distance, mention the minimum length of overtaking zones, and draw a neat sketch of overtaking zone and show the positions of the signposts. Solution. Overtaking side distance for two-way traffic is given by d1 plus d2 plus d3. Assume the design speed as the speed of the overtaking vehicle A, that is V is equal to 70 km per hour. If you convert it, you will get it 19.4 meters per second. And VB, that is slow moving vehicle, 40 is given. Therefore, you will get 11.1 meters per second. Acceleration A is equal to 0.99 meters per second. Therefore, D1 is equal to VB into T. Adopt small t, that is the reaction time of the driver, just 2 seconds, which you have learned from theory concept. You will get 22.2 meter. 22.2 meter. D2 is equal to VB multiplied by capital T, that is actual overtaking operation time, plus 2 times S, where S is the spacing that is given by an empirical formula, 0.7 VB plus 6, you will get 13.8 meter as S spacing for safety purpose. Therefore, actual overtaking operation time, capital T, is equal to under the root 4S by A, that is 4 multiplied by 13.8 divided by 0.99, you will get 7.47 seconds. Therefore, D2 is equal to 110.5 meter. Similarly, D3 is equal to small v multiplied by capital T, that will be equal to 144.9. Therefore, total OSD is equal to 277.6 meter. You can round it off to 278 meters. Therefore, as it has been asked in the question, what is the minimum length of overtaking zone? That is 3 times OSD. 3 multiplied by 278, you will get 834 meters. 834 meters. Desirable length of overtaking zone is 5 times that. Therefore, you will get 1390 meter. Overtaking zone figure you have to write. Simply you have to write here showing the distances whatever you have calculated. One OSD value. What was the 1 OSD value? That is 278 meter. So at 278 meter. If you provide the signpost at the beginning and at the end, driver will come to know when to start and when to end the overtaking operations. Second problem. Calculate the safe overtaking side distance for a design speed of 96 km per hour. Assume all other data suitably. So you have to assume all the data. Solution goes like this. OSD we know D1 plus D2 for one-way traffic, D1 plus D2 plus D3 for two-way traffic. Therefore, V given 96 km per hour, assume VB, that is speed of the slow moving vehicle, V dash minus 16, that is 80 km per hour. EA is equal to 2.5 km per hour per second. From table, you can get it. In exam, it will be given. Small t, total reaction time of the driver for overtaking operation is 2 seconds. Therefore, D1 is worked out to be equal to 44.8 meter. D2 is equal to 23 meter. S is equal to 22 meter. Capital T, actual overtaking operation time T is equal to 11.3 seconds. And D2 is equal to 397 meters. D3 is equal to 303.7 meters. Therefore, OSD for one-way traffic road, D1 plus D2, you have to add them and you have to keep it as result. For OSD for two-way traffic road, you have to add all the three, D1 plus D2 plus D3, because opposite vehicles are also expected. Whereas in the first case, since it is one-way traffic, there is no opposite vehicle. That's why only D1 plus D2. This is the concept. This concept you should remember. One way, there is no opposite vehicle is approaching you. Therefore, only D1 plus D2. In case of two-way traffic, there will be always opposite vehicles are approaching you. You have to add all the three D1 plus D2 plus D3. Refer once again figure, you will understand. Next, IRC specifications before we go to the horizontal alignment for design speeds on rural highways. Depending upon the different terrain, plain terrain, rolling terrain, mountainous terrain and steep terrain, the road based on classification of road, national highway, state highway, major district road, other district road and village roads, the maximum ruling and minimum speeds have been standardized. On NH and SH, in plain terrain, it will be 100 km per hour, minimum is 80 km per hour. Similarly, rolling 80, 65, mountainous 50, 40, steep 40, 30. You can refer this table. This is available in Justone Khanna book or any other textbooks. Easily you can understand this is the values. Right? Speed restrictions have been imposed for heavy vehicles other than passenger cars like buses, trucks and vehicles pulling trailer units under Motor Vehicles Act. Also, speed limits are specified for different categories of vehicles by regulatory signs on urban roads and on some stretches of rural highway when warranted due to traffic consideration. So, all these specifications are laid down by Motor Vehicle Act in the year 1939. It was amended. The recommended design speeds for different classes of urban roads. For arterial road 80 km per hour, for subarterial 60 km per hour, collector streets 50 km per hour and local streets just 30 km per hour. These speeds are required to be followed so that the safety can be achieved. Now design of horizontal alignment. A horizontal highway curve is a curve in plan to provide change in direction to the center line of a road. Depending upon the topography, invariably we have to change the direction from straight to curve. When a vehicle traverses a horizontal curve, the centrifugal force acts horizontally outwards through the center of gravity. For example, if this is the horizontal curve, the centrifugal force will act always horizontally outwards the curve. Let it be P. That is equal to WV squared by GR. where P is centrifugal force in kg, W weight of the vehicle in kg. Always weight of the vehicle will be acting downwards. W. R is the radius of the circular curve. V is the speed of the vehicle in meters per second. And G is acceleration due to gravity, 9.8 meters per second. You will see the good sketch or neat sketch ahead. P by W is known as the centrifugal ratio or the impact factor. This you have to remember. The ratio P by W is the impact factor. The centrifugal ratio is thus equal to V squared by GR. That is P by W is equal to V squared by GR. The centrifugal force acting on a vehicle negotiating a horizontal curve has two effects. One, tendency to overturn the vehicle outwards about the outer wheels. Tendency to skid the vehicle laterally outwards. Overturning effect. The equilibrium condition for overturning will occur when PH is equal to WB by 2 or when P by W is equal to H by B by 2H. This means that there is a danger of overturning when the centrifugal force or centrifugal ratio P by W or V squared by GR attains a value of B by 2H. Now transfer skidding effect. P is equal to FA plus FB, that is equal to F of RA plus RB, that is equal to F into W. So this component W can be taken as reactions RA and RB because there are two tires is considered. Since P is equal to FW, the centrifugal ratio P by W is equal to F. In other words, when the centrifugal ratio attains a value of coefficient of lateral friction, there is a danger of lateral skidding. Thus, to avoid overturning and lateral skidding on a horizontal curve, the centrifugal ratio should always be less than B by 2H and also F. F is less than B by 2H. The vehicle would skid and not overturn, whereas B by 2H is lower than F. The vehicle would overturn on the outer side before skidding. These are all the horizontal curves shown, with different radii. You can see very clearly, and you must have come across when you are traveling on roads. Superelevation. What is superelevation? In order to counteract the effect of centrifugal force and to reduce the tendency of the vehicle to overturn or skid, the outer edge of the pavement is raised with respect to the inner edge always, thus providing a transverse slope throughout the length of the horizontal curve. This transverse inclination to the pavement surface is known as superelevation, also known as cant, or another meaning banking. The superelevation E is expressed as the ratio of the height of outer edge with respect to the horizontal width. So it is denoted by E. E is equal to height of outer edge, that is considered as E, divided by total horizontal width B, that will be equal to small e. In the next slide you will come across this formula very clearly with figure. We will see here. You see that when the vehicle is negotiating the horizontal curve, when this is the direction of movement, this is the left hand curve that you have studied in surveying 1. This is the centroid force F. Centroid force F. This is the rise. E is equal to E by B, or E is equal to E by B, where E is the outer edge of the pavement is raised with respect to inner edge. This is the outer edge, this is the inner edge with respect to left hand curve. So superelevation, transverse frictional coefficient because of these two wheels. Now superelevation analysis. For that, all the forces are resolved into horizontal and vertical, that is horizontal parallel to the inclined surface, parallel to the inclined surface, you have to resolve, and perpendicular to this you have to resolve. So when you resolve, you will get these forces. These are all mentioned here. Now when in the analysis we will come to know how it is done. The force acting on the vehicle, okay, analysis of superelevation may take more time. Today it's enough. Thank you very much for patient hearing. We will continue in the next class, analysis of superelevation. Okay.